And we're going to look at just the two techniques, which is the GCF and a difference of two squares. So, what you see on the board when it comes up, if you will make sure you're writing this down. All right, helpful polynomial vocabulary for factoring. A monomial is a polynomial with only one term. Okay? A monomial is a polynomial with only one term. So like 3x squared is one term. 9 is one term. 2xy is one term. A binomial is a polynomial with two terms. So for example, 4x plus 1. So go ahead and you should be writing in the notes what you see up here on the board.
Question, what's a polynomial?
A polynomial is a function that we have that has, it can have one or more letters, but the exponents are whole numbers. So it can't have a negative exponent, it can't have a fraction exponent, but it can be x to the 0, x to the 1, x to the 2. Good question. Then a trinomial is a polynomial with three terms. So 2x squared plus 4x plus 1. Then, if you see down below, go ahead and write what I have here in green underneath factoring.
When do we get into like, I know that we're like continuing to learn like new stuff, but like when do we get like really into algebra too, like new stuff?
That's a great question. We're in this chapter, we're going to get into complex numbers. So this chapter, and then
Doesn't second semester once we hit second semester, like
it'll get a lot more challenging in the second semester. And then partway through chapter 5, we'll do polynomial long division, synthetic division. So I would say about 2/3.
That's so thrilling.
Are you?
2/3 of
teach us how to do long division again because
Yeah.
I didn't know I was like trying to do multiplication. I'm like,
I was trying to put
yeah,
it into
yeah.
10 and then I didn't understand. Yeah, you gotta teach.
Yeah, how about after the notes, I'll pause because we have a plus today that my other class didn't have. I can go over how you do that because we actually do need to know how to do that for polynomial long division.
Long
I
division?
know.
What's that even?
What is that? I didn't even know how to multiply.
Hey guys.
it'll bring someone a little laughter.
Okay, so factoring. Okay, so factoring is rewriting as multiplication, and we will always do this completely. Step 1 in factoring is to look for the GCF. All right, so here we go. I'm going to show you two different techniques. I personally will use the first one, but if you struggle with your number sense, this might be a little bit harder for you. So I'll show you the second method. All right, when I look for a GCF, I'm looking for the biggest number that divides evenly into both numbers. So when you look at 25 and 35, what number goes into both? 5. Okay. So that's like I look at them and I can tell what numbers go in. And then they both have an x, but the first one doesn't have x cubed. It only has an x times an x in it, an x squared. So my GCF would be 5x squared.
What about the y?
Well, we're looking for what's called a common factor. They both don't have a y, and they both have an x, but so like if I wrote that out, that's x times x, and this one's x times x times x. So what do they both have? They both have 2 x's. Okay, they both don't have 3 x's. All right, so now, when I look at number 2, so the GCF on number 1 is 5x squared. Those go into both numbers evenly, and letters. So if I look at number 2, and I have 36 and 108, all right, even I can't tell immediately what is the biggest that goes into both. So let me show you a technique, and you use this. You've actually used this back in 4th and 5th grade where you did You did GCF with numbers and you did a factor tree.
What goes into 36 and then you're sitting there like, I don't even know.
Okay, so here's what we're gonna do. We're gonna do a factor tree. 2 times 18 is 36. 2 times 9 is 18, and 9 is 3 times 3. So what we're doing is we're making a prime factor tree.
Is this where you cross it out? Like,
Not cross it out, but we're gonna circle them. We're gonna circle them.
goes
So
into
watch
the-
this.
It goes-
It
was last year.
Love you.
So 108 is even. So 2 goes in there 54 times. 54 is even, so I divide it and I get 27. 3 goes in there 9 times, and 9 is 3 times 3. So to do a GCF, okay, to do a GCF, I am looking for common factors, a factor that they both have. So I see a 2, and I see another 2. They each have a 3 and another 3. So it's 2 times 2 times 3 times 3.
What about 9? You both have 9.
Okay, we're getting down to, we rewrote 9 as 3 times 3. So I can't count it twice. Okay, I can't count the 9. Okay, so
What about
you
the
get it
other?
down to prime numbers. 2, 3, 5, 7, 11 prime. Yeah.
What about the other 3? That's unbelievable.
Okay, now we're looking for what's common. This one doesn't have an extra 3. So I circled the ones that they have in common. This one's an extra one. All right, now let's look at the letters.
Wait, there's 3 of each though.
No, I have 2 2s that they both have, and they both have 2 3s. They both don't have 3 3s, so I can't put the extra 3 down. Ryan, did you have a question?
Yeah, like I'm
One,
just confused
two,
because there's
three,
like
four,
4
four.
2s, and why is there only like 2 2s?
Yeah.
Okay, do you see up here? This was 5 times 5 and 5 times 7. I didn't put 2 5s down. I'm asking myself, what is the number or factors that's common to both? So it's not that there's 4 2s. They each have 2 2s.
Okay.
Okay?
Yeah.
I'm not counting all the numbers I'm circling. It's what do they have in common? They both have 2 2s and they both have 2 3s. So that's why it's 2 times 2 times 3 times 3. You're not counting up everything that I circled. All right, now let's look at the letters. They both have an A, and they're both to the first power, so there's an A. They both don't have B's, so I can't, B is not common. They both have C's,
C to the 3rd.
C to the 3rd, because they both have a C to the 3rd. This one doesn't have an extra C for C to the 4th.
Got that.
So the GCF, now I'm going to multiply, and it's okay guys, I just need you to stay with me, and we'll do some more practice to get where we need. So 2 times 2 is 4, and this is 9. 4 times 9 is 36 AC cubed. So that is my GCF. Yeah,
Can you just divide them by each other?
you can, but like 35 divided by 25, that wouldn't give you the GCF. This is a coincidence that 108 divided by 36 went in evenly. So not in general, you cannot. Okay, when you're ready, let's flip the page. We're going to do some more practice here. And I want you, when the numbers are small, I don't have to do the factor tree. I only do the factor tree when the numbers are really big. Okay? So, this one says we want to factor. Okay, now, factor means rewrite as multiplication. I did not say find the GCF in the original directions, okay? And I need you to make sure you're really leaning in and listening. If it says find the GCF, I only want the GCF. But if it says factor with the GCF, factor means write it as multiplication. And I have that here. Factor means rewrite as multiplication. So, if I have 14x to the 4th minus 21x squared, what is the number that goes into both? What's the biggest number that goes into 14 and 21? 7. Okay. So the GCF is 7. I'm not even going to do 1 and 2. Only do that if you need your factor tree, okay? Now, they both have an x, but what is the biggest number of x's that they both have?
So do you use the factor tree whenever you don't know what the greatest common factor is?
Yes, only use the factor tree if you don't know what the number GCF is. Otherwise, like, you just look at it. I'm not going to make you do factor trees. So, they both have an x squared. So there's the GCF. If I want to rewrite this as multiplication, okay, if I want to rewrite this as multiplication, what that means is 7x squared, what would I have to multiply it by to produce 14x to the fourth? Macy?
With the exponents, do you add, or
Yes,
what is that? You add, okay, so wouldn't it be 2x to the second?
Yes, 2x squared minus, and then what do we need here? 3. Okay, so let's kind of pause here and think. When you factor, the word factor means rewrite it as multiplication. You can, now here's the beauty of factoring. I can always check my work. I can tell myself whether I've done it right or wrong. You don't need my answer key. You don't need to ask me. You check yourselves. 7x squared times 2x squared, that's 14x to the fourth. 7x squared minus 3 is minus 21x squared. I go look at my problem. Hey, I did it right. All right.
What is expand? Like, what do you mean by expand?
Oh, expanding was factor tree, but
that wasn't me. That was
Oh. Yeah, sorry. That means like factor tree, but you don't have to use the factor tree. All right, so now let's look at this next slide. It says you're going to factor, and the word factor means rewrite as multiplication. You're going to pull out the GCF. Now, a GCF has to come out of all the terms. So in this one, I have a trinomial because there's 3 terms. What number goes into all 3? 2. Is there a letter or letters that are on all 3 terms? X. And they don't all have x squared, so it has to be just x to the first. So then I start a parenthesis, and you understand this is reverse distributive property. You remember how with the distributive you multiply it out? Well, the distributive property works in the reverse when we call it factoring. So this will give me 4x plus 9y. Now, if I close my parenthesis here, which don't do it, but if I were to close it, how many terms would this produce if I multiplied it back out? 2. How many terms do I have?
3.
Okay, so you can't close it because I need it to produce 3 terms. So what do I need to put here?
1.
1. Good job, okay? And check your work when you factor. I personally check mentally, but if you're the type of person that if you don't actually write it out, you're not going to check it, then you need to write it out. 2x times 4x is 8x squared. 2x times 9y is 18xy. And 2x times 1 is 2x. So here's my answer that I'm putting in the box. The check is just a check to make sure I did it right. All right, I'm going to pause, and I want you to try number 4 on your own. This one's a little bit harder.
I'm going to
Would it be 3x to the third? And then y to the third?
Yes, there you go. Okay, here's the GCF. 3x cubed, y cubed. Okay, they all have a 3 factor. They all have a y cubed, and they all have an x cubed. So then this will be what? 1 minus 5x squared plus 3xy squared. Okay, what's 3xy, 3x cubed, y cubed? How do I get it back? It has to be just like, here's where I got this one. same thing. I need this term to come back. So if I need this one, I need a 1. Yeah, Ava?
How did you get 5x squared? I know the 5, but the x squared.
Okay, x cubed times what gives me x to the 5th. So, and that's what Macy asked about the adding the exponents. Like,
So you just add them.
you add the exponents together. Claire?
Wait, can you like explain how you did that for each one of the exponents?
Absolutely. Okay. Are you okay with the GCF is 3x cubed y cubed? Okay. So 3x cubed y cubed times 1 produces itself. 3 times what is 15? That's the 5. I already have the y cubed. And then x cubed times x squared is x to the 5th. And maybe let me refresh your memory on an Algebra 1 exponent property. If you have from Algebra 1 a to the m times a to the n, that's a to the m plus n. So if I have x squared times x cubed, that's x to the 5th.
There's a little thing that you would say with it. What's it?
I don't have a little thing.
Oh, power to a power.
Power to. There we go.
Multiply the power. Like basis, you add. Power to a power, you multiply the power. Like basis, you add.
Oh, cool. I don't
Yeah,
know
I
that.
was like, I knew there was something.
How did you get the 3xy squared?
Okay, so 3 times 3 is 9.
Then we had to write.
X cubed times x to the 1st is x to the 4th. Y cubed times y squared is y to the 5th. Because I'm using this, when you multiply the bases, you add the exponents. Okay? All right, so now down at the bottom, don't flip it too soon. It says always check for the GCF before factoring any polynomial. It is helpful to factor out a negative 1 if the leading coefficient is negative. So we'll see that in a moment. All right, now here's a beautiful connection to what I had you guys do on Tuesday after the quiz. Like I was trying to set you up for success. This a squared minus b squared. The reason why I had you practice multiplying, and I had you do the pink papers around the room, and then the riddle about the Roman numerals, is that I wanted you to see that if you did a plus times a minus, the outer and inner canceled every single time. So,
Are you gonna give us that on the test?
no. You should know that now. Like, because you did this in Algebra 1. This isn't new, right? Yeah. This should be coming, the cobweb's coming out. So 8 squared minus b squared factors into a minus b times a plus b. So in number 5, if I have x squared minus 16, this is what we call a difference of two perfect squares. And what I mean by a perfect square is x times x is x squared, 4 times 4 is 16. This is going to factor, and it doesn't matter if you put the plus or the minus first. You just need one of each, okay? So this is x plus 4 times x minus 4. In number 6, don't forget about step 1 is look for the GCF. In number 6, I have 9y squared minus 36. What's the GCF here? So you get 9 times the quantity, y squared minus 4. So then that's 9 times y plus 2 times y minus 2. So don't forget about step 1. You always do that before anything else. Then, once you get down to there's no GCF or you got the GCF out, what we're learning today is if there's two terms, we're going to look for a difference. And I need you to really look at the word difference.
So did you just put the 9 out there because it's in front of the y?
No, I put it out there because 9 is a common factor to 9 and 36. So I pulled the 9 out of both. I factored out the GCF. All right, so now try 7 and 8 for me. Okay, try 7 and 8.
I've had him for like, is that Raz? These are so
Yeah,
loud.
that's like Raz.
Yeah, I love him.
Stop. Okay, so this is what, 4x plus 5 and 4x minus 5. Okay, that's a difference of two perfect squares. In number 8, is there a GCF? No. Is this a difference of two squares?
Yeah.
No, because 3, what times itself? Times itself, okay? Like 16 is 4 times itself, 4 times 4. 25 is 5 times 5. What times itself is 3? There's no number times itself, no integer value. So this one does not factor, and if you remember from Algebra 1, we said it's prime.
So is for 7 is so you found the like the greatest common factor for
No, I did not find a greatest common factor.
see because 16 goes into 4 and 4, so that's where you got the 4, right?
Yes.
And then
So you're
25
just
goes
reducing
into 5 and 5, right?
Okay, what I'm doing, let me go back a slide. When you have a difference of two squares, a squared minus b squared, it factors into a minus b times a plus b. And what you practiced after the last quiz
So yes.
was you foiled them. But it's not a GCF. Okay, a GCF is like 9 came out of both.
Okay. So that's a factor.
That's a GCF. That's a common
Yes,
factor.
but the one on that.
On this one, there's no GCF. I factored it as a difference of two squares. It's not a GCF. Okay? A GCF is the greatest common factor that comes out of every term that you have. I didn't pull a 4 out of 25. Okay? All right. So number 8 is prime. So now flip here, and then we're going to add a number 11. But in number 9, there is a GCF. What is the greatest common factor in number 9? What comes out of both numbers? 5. Nice. Okay. So there's a GCF. Okay. So a GCF is a greatest common factor that comes out of every term. So there is a factor of 5. Now, you've got to stop and ask yourself, can I continue to factor? Look at 4m squared minus 9n squared. Hey, that's a difference of two squares. So this is 5 times 2m plus 3n, 2m minus 3n. So Macy, I think what you were saying is like if you can tell that the first term is a perfect square times itself, and the second term is times itself, then yes, you keep going as a difference of two squares. Okay. All right, number 10. 64x squared minus y squared. Is there a GCF? Can I pull something out of both terms? No. Is it a difference of two squares?
Yes.
Yes. All right, there we go. So it's 8x plus y, 8x minus y, and I'm done. Now, I want you to add a number 11 on the bottom half of this side, okay? And I don't want, well, you can try this one. I want you to call it number 11, and we're going to say x squared plus 9. Now, this is not a difference because I don't have a subtract sign. Do you see that? This is a plus, so that's not a squared minus b squared. This is not this situation, a squared minus b squared. This is not the same. So let's say I think it's going to be, because it's a plus, I'm going to change them to both pluses. If I FOIL here and I do x plus 3 times x plus 3, that's x squared. I get a 3x plus a 3x. That doesn't cancel. So x squared plus 9 is not x plus 3 times x plus 3. It didn't work. Now, you might say, okay, I know that if I make one a plus and one a minus, that's x squared minus 3x plus 3x minus 9. Hey, that's going to make the outer and the inner cancel, but what's my problem? It's a subtract. This doesn't work. All right, well, there's one more possibility. What if I make them both minuses? Okay, if I FOIL this, does that outer and inner cancel? No. Minus 3x minus 3x is minus 6x. There's no more options here. These are all the options that I can try. So guess what? The sum of two squares is prime, and I'm going to say this over the set of real numbers. We're going to learn something later in chapter 4 called the complex numbers, imaginary. It will factor over the imaginary, but it's not going to factor over what we know so far.